Today's video is on what's the derivative of e to the x. So I'm saying if we had y equals e to the x, what is y prime? Well, you're about to learn one of the easiest rules from calculus. The derivative of e to the x is e to the x. Yup. So if you had y equals 4e to the x, its derivative would be, well, 4 is a coefficient. It just comes along for the ride. And the derivative of e to the x is e to the x. Pretty easy so far, right? Well, don't forget, we still have our product rule, chain rule, all of that good stuff. So if I had a function which was x squared plus e to the x, the derivative of x squared e to the x would be, well, the derivative of x squared is 2x. The derivative of e to the x is e to the x. All right. Now, if it was instead x squared times e to the x, this would be product rule. And you guys have seen in class how I do product rule. I do u equals x squared, v equals e to the x. U prime is 2x, v prime is e to the x, and then we'll cross multiply to glue them together. So I would get x squared times e to the x plus 2x e to the x. So that would be my derivative. Now, I will warn you that most textbooks, if this were a textbook problem, they would actually have their final answer in factored form. So they would say that everything has an x e to the x in common. So I would have an x plus 2 left behind. But the two answers are equivalent. All right, pretty fast, right? We're going to do one last example that involves chain rule. So if I had y equals, how about 3e to the x plus 7 all to the fifth? Okay, so 3e to the x plus 7 all to the fifth. Well, chain rule says I take the derivative of the outside, which is the power. So the 5 will come down. We leave the inside alone. Drop that to an exponent of 4, and then we tag on the derivative of the inside. The derivative of 3e to the x is 3e to the x. The derivative of 7 is 0. So my final answer is I'm going to move this to the front of the line with that 5. So 5 times 3x would be 15e to the x, 3e to the x plus 7 all to the fourth. That would be the derivative. All right.